Let's take a look on this problem. A woman is considering two types of steel structure for her 25 feet column. And because the column is tall, so her main concern is that the column buckling is an issue with the construction project. So which one you should recommend her? Option A, my mistake, this one, option B. So option A, we have the pipe number 8 standard steel. And option B, we have the wide flange beam 30 by 90. The hint over here is that you should consider the slenderness of the two options. And then you can consider the potential cost of the two options. As I mentioned previously, if the slenderness of the column or a building indicate the ability of that structure to resist to the buckling, the small slenderness indicate that is a good column or a good structure to resist to buckling, and high slenderness is a concern. So if you forget that, you can always go back to my formula over here, and if you go all the way up, you can see I have some note over here. So you see that I put a note here. So large R or small slenderness ratio is more buckling strength for a column than at is good. So remember, for me, small slenderness is good. Alright, so how can we calculate the slenderness? The slenderness ratio is just equal to K multiplied by L divided by R. And K multiplied by L, as I indicate on the video, the lecture video, that is the effective length of the column. So we have here, you see that we have that one is a fixed support. So K will be 0.65. Okay, and L over here, because R typically we use that one in inches, so L no is that you should put this one in inches as well. So we have this one is 25 feet. So first of all, I'm going to convert 25 feet to inches, and I'm going to multiply that one by 12. I have 300 inches. Okay. Alright, so K is 0.65 and L is 300. So now let's take a look at A, option A over here. What you can do, you can go to the reference. Let me put, you can go here and go to AWC, American Good Council over here, to make it easy for doing the highlight. I open that one in Bluebeam, so we can easily do the highlight. Oh, sorry, this one is steel. For steel, we need to open the AISC. My bad, AISC over here. So we should open AISC, and we can go down to pipe. Alright, pipe here. So pipe number A. I have the pipe number A over here, and the R of that one is radius of gyration is 2.95. So I'm gonna put here is 2.95 inches. This one also inches. So we're gonna have this one is 0.65 multiplied by 300 divided by 2.95. I have that one is 66, around 0.1. Okay. For B, we're gonna do the same thing. However, for B, the R of 30 by 90 will be different. So we need to look for 30 by 90. So if I go all the way up here, and I check 30 by 90, and go to this page and check for radius of gyration. So I have two options over here. However, for the formula, if you check the formula for save, we should calculate the minimum radius of gyration over here. So the minimum of radius of gyration is 2.09. Okay, to 2.09. So I'm gonna have this one is 93.3. So you see that option A has smaller slenderness ratio. So A will resist buckling better. Okay. And now, so we know that A will resist the buckling better. Next thing is that we should consider the cost, because maybe A resists buckling better, but A is more expensive. So now we check A. So for A over here, you see that the cost of A, you can go all the way down here, and you say nominal weight is 28.6 pounds for one linear feet. So I'm gonna put here unit weight of A is 28.6 pound for one linear feet, and unit weight of B, and like we discussed previously, this one indicate the nominal height of the cross section, and this one indicate the unit weight. So the unit weight of that one is 90. If you forgot how to check for that, you can also go back here to check for the nominal unit weight over here. That one is 90. Okay. So this one is 90. So we have that option A is cheaper. Why? Because it uses less steel, so it obviously is will cheaper than B. Okay. So we have A is stronger and A is cheaper. So you can see that obviously we should use A. We should use A for the project. Okay.